Today's daily dose of math is about four transformations: the translation, the reflection, the rotation, and the size transformation, which students in the course I'm making this video for are responsible for understanding and being able to draw. Over here on the whiteboard I have some examples, but I didn't bother drawing an example of a translation or a reflection because those are the simplest ones that students understand the most easily. But I'll still show an example. Let's say my original is this blue marker. And let's say it's a translation and it's going to be in a horizontal direction going to the right of about 40 centimeters. That's what can also be called a slide. And what's going to happen is the copy will be a slid over version of the original 40 centimeters to the right. So students find that pretty easy, which is why I didn't bother drawing an example. And then the reflection students find just as easy. The reflection, let's say the copy is the blue whiteboard marker and the green ruler is the mirror line. A reflection will have the original landing something like this. And you can see the copy on the other side of the mirror from the original. Pretty straightforward. Then we get the rotation and the size transformation. I have the rotation example here on the bottom. In this case, my original is here. The copy is there. I'm labeling the original as ABC, therefore the copy is A prime, B prime, C prime. And what I'm showing is a 90-degree clockwise rotation around this point. Here's where the copy lands. Finally, I have a couple examples of size transformations. I could have shown a lot of examples if I had space, because a lot of things can happen with size transformations. But what I'm choosing to show here are size transformations where the k-value is negative. When the k-value is negative, the copy lands on the other side of the 0 dot from the original. So here's my original. The copy's over on the other side. The 1/2 means the copy is going to be half as big as the original and half as far from the 0 dot as the original. And I tried to show that. My copy is half as big as the original, half as far from the 0 dot. Then I have another example up here on the top where k equals -2. Again, k is negative, so the copy lands on the other side of the 0 dot from the original. This time it's 2, so it's twice as big. The copy is twice as big as the original and twice as far from the 0 dot as the original. That's enough examples so we can talk about these four examples on the chalkboard. One of the things that happens with this topic is it becomes tricky to ask students questions because there can be more than one correct answer. So in this case, the question is, here's my original on the left side in all four cases, and here's my copy on the right side in all four cases. What transformation happened? And try to justify your answer. So what I'm showing is really the same example 4 times, but I'm going to give it all 4 different possible answers. For the top one, I'm going to say this is a translation. It's a translation of 15 centimeters to the right. And now I have to finish labeling it. So if my original rectangle was ABCD, my copy rectangle has to be A prime, B prime, C prime, D prime, and I have to make sure that I put them in the right places. Now this makes sense. We have a translation to the right, 15 centimeters. Here's the original, there's the copy. In the second example, I'm going to say, oh, no, it's not a translation. It's a reflection. And that can also be a correct answer depending on where I draw my mirror line. So there's my mirror line. I give it the letter S, the designation for a reflection. And I've drawn it halfway between the two shapes because that's the only place to put the mirror line. Well, this will make sense. In this case, vertex A ends up over here for A prime. Therefore, D prime is here, C prime is here, B prime is there. Notice how they landed in different positions than they did for the translation. So you have to be careful how you label it if you want to be given credit for a correct and complete answer. The third one I'm going to do is going to be the size transformation. And I know from what we discussed earlier, I know the only way, if I make my 0 dot here, the only way this is going to make sense is if my k is negative. So my k value is negative, but negative what? Well, the copy is the same size as the original, so it has to be a k value of -1. So by placing my 0 dot in the right place and choosing the correct k value, both in its sign and in its size, I end up being able to show that yes, this can also be seen as a size transformation. Finally, I put the rotation on the bottom because I need the most room to show it. If my 0 dot for the rotation is here, then the only way to make this work is if I call this a 180-degree rotation. Now, I'm going clockwise, but if I chose to say it was counterclockwise, that would also work. For a 180-degree rotation, clockwise and counterclockwise end up in the same place. After the rotation, the A prime will be down here, the B prime will be here, C prime here, D prime here. Yep, so this makes sense as well. We also can show a 180-degree clockwise or counterclockwise rotation if we put the 0 dot in the right place. And we have another correct and complete answer. One thing I forgot to do is to complete the answer for my size transformation in the form of labeling the vertices. If A is here, A prime ends up here. D prime ends up here. B prime, C prime. Well, that's interesting. The rotation answer and the size transformation answer ended up with the copies labeling being the same. Anyway, what really comes out of this is the amount of flexibility a student has when they're given a transformation situation and asked to say, well, what type of transformation is this? Sometimes there's only one correct answer, but in this case I showed that there were 4 possible correct answers. That is today's Daily Dose of Math. Please like, subscribe, and share.